back to waves. So, we've been talking a bit about waves, and Forrest Gump has really led the way. A wave is as a wave does. That's a fundamental principle here. So what does a wave does? I mean, what does a wave do? The things we've done so far, we've talked about waves transmitting. That means the wave, some energy is going from one place to another. It travels, but it doesn't bring mass with it. What else do waves do? Waves can be absorbed. So that means some of that wave energy as it transmits from one place to another gets absorbed or gets lost to the medium it's traveling through. So that energy somehow goes to other things. We also talked about waves reflecting. And so that's when the wave travels, it meets a new boundary, hits it, bounces off, and comes back into the first one. Finally, we talked about wave refraction. So like reflection, the wave is transmitting, it meets a new boundary, but it doesn't all reflect. Some of it actually transmits into the new medium, into the new material. And when it does, it appears to bend. We practice some of that. So now we're going to start with a new wave phenomenon, one called diffraction. A little bit different than the others. And we're going to go through a number of examples of diffraction. So let's give you some examples just to get you up to speed with where we are. One of the things we said was that, again, a wave is as a wave does. So if we can say that something transmits, energy not mass, absorbs, reflects, refracts, and as you'll see later today, diffracts, well then we can call that thing a wave. Our claim was that light was a wave, sound is a wave. So how do we know? Does light transmit? Well, sure it does. How do you see me? The light is going from here to the camera. Here is a sharper example of light transmitting. We'll blind you just for a moment. Ready, ready? Oh, that's terrible, I know. Sound also transmits. You can hear it coming from here to you. Okay, so transmission's easy. Absorption also happens. Go outside in the sun wearing a dark shirt, hot day. What happens? Well, some of the light somehow disappears when it reaches your dark shirt. It's not as bright as it was, yet you feel warmer. Some of that light energy is being absorbed. Sound also can be absorbed. You take a house that is unfurnished and furnish it. Put couches and furniture and books and all the rest of that in the house, and suddenly when you speak, it's much quieter because some of the sound is being absorbed. We also had light reflecting. Here's a little reflection. So light reflecting, we can do the same thing. Can we blind you again? Maybe. Oh, do you want it twice? There it is. Okay. Sound reflects as well. In fact, you can get sound reflection in lots of scenarios. Even here, you can hear the sound reflecting. If you bring it next to your head, it's no problem. I'd had to do that in class. All right, finally, we did refraction. Did light refract? Well, yes, it did. Here's our wine glass. And so, mix a little chalk dust in there. And one of the things you will hopefully see here, we'll shut the lights, we'll use our red laser again, and hopefully you can see a little reflection off the ends of the laser. And then you can notice that that reflection does not quite line up with the direction that the light ray is traveling in the glass. So you see, that's what we practiced before. That was refraction. Light bends when it enters that new medium. Does sound refract? Yes. However, we don't use it nearly as frequently. Light refraction we actually use to make lenses, and lenses for your glasses and telescopes and things of that sort. But sound refraction, we don't use that frequently. It's harder to get an example. An example that you could perhaps come across is if you're an early morning fisherman, go out on a cool lake, the sun has just risen, so the air above the lake is warming up, but immediately above the lake is still cool, and strangely you can speak in a low tone, and your voice travels very far, and one of the reasons is as you speak, the sound goes through the cool air, enters the warm air, and it actually refracts, it bends, and brings it back down to whoever may be listening to you on the other side of the lake. All right, so now we're off to diffraction, and we'll see some cool demos in our next video.